Today we're going to continue with transformations and talk about our second type of transformation called a reflection. And sometimes you'll hear reflections referred to as a flip. And that's exactly what happens in a reflection. A reflection is created when one object is a mirror image of another. If you think back to elementary school, when you finger painted on one side of the page and then you folded the paper in half, and then when you open it up you had an exact replica of what you originally painted, only in reverse. And that's exactly what a reflection is. A butterfly is a perfect example of a reflection in nature. Here we have a reflection on a graph. Remember, we need to pay attention to the vertices or the names of the vertices to determine which object is our pre-image and which object is our image. And remember, A, B, C, D is going to be our pre-image before reflection, and A prime, B prime, C prime, D prime is our image that's created by reflecting our original shape. First, we're going to talk about the type of reflection that's happened here. And when we discuss the type of reflection, we want to know across which line our object was actually reflected. Going back to that elementary school example, we want to know where the fold was on the paper to create our reflection. In this case, if I took this graph and folded it right along the y-axis, the two shapes would perfectly meet up on the page. So we call this type of reflection a reflection across the y-axis. Notice that point B is exactly 4 units to the left of the y-axis. Point B prime is exactly 4 units to the right of the y-axis. Same thing with C. Same thing with D, right? They're all equidistant from the y-axis, the pre-image and the image points. That's how we know that the y-axis is our reflection line. When we talk about arrow notation, actually I first want to talk about the coordinates for our reflection. We have our original pre-image points, A, B, C, and D, and I have their coordinates. And then I have my prime points or my image points, and let's do a little comparison. Let's look at point A, which was originally at -6, 8, and became, when it was reflected, +6, 8. Point B, -4, 8, became +4, 8. -5, 4 became +5, 4, and so on. So what was the change from pre-image to image? The actual numbers didn't trade places or anything like that, right? The only thing that happened in every single instance was we changed the sign on the X value only. The Y value stayed the same, just the X value changed sign. So when I write the arrow notation for our reflection, I'm going to use R for reflection, of course, and that's going to tell me to take every point XY and change it so that the X now has a new sign and the Y value stayed the same. Remember, -X doesn't mean that X has to be negative in my new point. It just means to take the opposite sign of what was originally there. When we shorten the notation or abbreviate the notation, we say that this is a reflection across the y-axis, and y-axis is a subscript here. Any reflection, any object being reflected across the y-axis will simply have the X value change sign in its coordinate. Now let's take a look at a different type of reflection. Notice which object is our pre-image and which object is our image. Remember, when we talk about what type of reflection we're talking about, we want to know what line the object was reflected across. Or, again, with that elementary school folding of paper, where could I fold this graph and have the two objects meet perfectly together? Point A meeting with A prime, B meeting with B prime, and so on. In this case, it would be the x-axis, right? So we call this a reflection across the x-axis. Notice that point C is 2 units away from the x-axis. Point C prime is 2 units away from the x-axis. B is 4 units away. B prime is 4 units away. And that will happen with every point from pre-image to image. Next, let's take a look at the coordinates so that we can know what notation to write. If I go from pre-image to image, let's take a look at point A very first. -3, 6 became, after reflection, -3, -6. Point B, -2, +4 became -2, -4. Compare the points and see if you can find the change. Hopefully what you're seeing is that the x value this time didn't change at all, but the y value changed sign. Or I should say went to the opposite sign. That will happen with any reflection across the x-axis. So when we write our arrow notation, a reflection takes every point xy and changes it to x and the opposite of y. The shortened or abbreviated notation is a reflection across the x-axis. Just a quick review of our arrow notation. Any reflection across the y-axis, you're going to change sign on the x value only. Across the x-axis, we're going to change sign on the y value only. So let's do just a little bit of practice. If I go from point J, 5, 7, to J prime, 5, -7, what type of reflection happened? That would be a reflection across the x-axis, since it was the y value that changed sign. From -4, -1 to +4, -1 would be a reflection across the y-axis. Sometimes you'll be given the coordinates of the pre-image and you're asked to find the coordinates of the image given what reflection has taken place. In this case, point L at -3, 2 is being reflected across the y-axis, and we want to find the coordinates of the new image. Since a reflection across the y-axis changes sign on the x-coordinate, our new L prime would be a +3, 2. And if point M was reflected across the x-axis, we'd get a point M prime at 8, -6. All right, I think that wraps up today's lesson. I hope you have a great day, and of course, I'll see you next time.